Left, right, up, and down. This gun will move left and right, up and down, and follow it. All you got to do is pull the trigger.
The Apache is also equipped with state-of-the-art sensors located on top of the rotor and on the bottom of the nose that allow pilots to see any enemies they can see.
The part on top of that is a new sight for the longbow radar. It's the fire control radar system. We can look out with a millimeter wave radar, look for tanks in the open, get all that data to our computers. That'll transfer it to a firing solution.
Night combat presents few. Unlike the Apache that's designed for the specific purpose of attack, the Black Hawk serves a multi-purpose role.
This is a UH-60 Mike model Black Hawk, and the UH-60 is a utility helicopter. The UH-60 is probably one of the most versatile aircraft in the Army, and it can conduct mission from ranges of air assault operations in combat, which we can take fully loaded combat soldiers in air assault missions onto the battlefield. And then we can turn around and pick up logistical supplies from sling loading water, pallets or MRE pallets, or ammunition to help resupply soldiers. We can do medevac missions, which is picking up casualties on the battlefield, delivering to the medical treatment facilities, which has drastically increased the survivability on the battlefield.
Number 1 and number 2 battery utility bus circuit breakers are in.
The Black Hawk helicopter crew includes 2 pilots. To fly it, the pilots must use both hands and feet. The helicopter's superior maneuverability comes with complexity. The key to understanding how to fly a Black Hawk or any helicopter starts at the hub.
The hub is a central portion of the rotor system. It's the part where all 4 rotor blades hook together.
The hub or rotor disc tilts to give the helicopter directional flight and is controlled by the cyclic.
This is the cyclic. This provides us directional control, either at a hover or in a cruise flight mode. With a cyclic, I'm actually tilting the rotor disc in the direction that I'm pushing the cyclic. So therefore, if I'm at a hover and I move the cyclic to the right, then the aircraft rotor disc is going to tilt to the right and I'm going to drift to the right. If I push the cyclic forward, the rotor system is going to tilt forward, the aircraft is going to go into a descent, and I look outside and the houses on the ground are actually getting bigger because I'm getting closer to the ground.
To control the lift or thrust of the helicopter, the pilot uses the collective.
The flight control that I have in my left hand here is called the collective. And it's called the collective because it collectively puts blade pitch angle into all 4 rotor blades at the same time. The more pitch I want in the rotor blade, the higher I pull the collective.
The pitch angle determines how fast or how fast it will fly in flight. A 0 angle will produce 0 lift. As the pitch increases, the blades will push more air downward. As the pilot flies the aircraft, he uses the tail rotor to keep the nose of the helicopter pointing forward.
The purpose of that tail rotor is to provide thrust in the opposite direction of the main rotor turning so that we can maintain our directional flight.
Since the main rotor system turns counterclockwise, an opposite reaction that forces the fuselage clockwise. Tail rotor counters that. It works the same way as the blades increase pitch to gain thrust. To maintain a pitch that will keep the